going to take some notes in today's science notebook, but before we do, you need to pull them out and you're going to have to cut them apart. So these are Newton's laws. They're in your paper clipped packet of notes, but there's 4 of them. So you need to cut them into 4, you need to cut them into 4 rectangles, or 4 squares. Those are rectangles. There's this one that has 2 other Newton's laws on it, and you need to cut that in half. And then finally, there are some scenario cards. There are 3 sheets. There are 4 cards on a sheet. So you need to cut these 4 scenario cards, these 4 scenario cards, and these 4 scenario cards. So pull all that out of your paper clipped packet of notes and cut them all apart. So pause the video and get that done, and then when you are finished cutting it all out, you can unpause the video. So you should already have your scenario cards and your Newton's laws cut apart. So now you're going to turn to your table of contents, and you're going to write Newton's laws, ... page 58 to 66. So this will be quite a few pages of Newton's laws that we will be gluing down today. So then you're going to turn to page 58. And on page 58, I want you to glue down this Newton's laws of inertia. And it gives you an example that the vehicle stops, but like in a car, the vehicle stops, but the body's inertia keeps the body moving forward. We actually should have put this one on page 58, but I wasn't paying attention when I glued down. So that's fine. We'll put the example first of the law of inertia. So like when you're in a car, so when the car stops suddenly, your body keeps going forward because your body's keeping that inertia, keeping that momentum. The only thing that stops you is the seatbelt. So on page 59, you're going to glue down this page. The law of inertia states that the motion of an object will change only if an unbalanced force acts upon it. So back in our example of the kid in this car again, the object's motion, the car's going forward and therefore so is the boy, and the only reason that the object changes position is because the car changes its motion because somebody hits the brakes. The boy doesn't change his motion until the unbalanced force of the seatbelt acts upon him. Same thing here. Here the soccer ball is resting on the ground, so that's a balanced force. And then when the soccer ball is kicked, that's an unbalanced force, and the soccer ball will move. On page 60, you're going to glue down this page. Newton's law of inertia states an object at rest will stay at rest. So like that soccer ball stays sitting there. Or an object in motion will stay in motion in the same direction at a constant speed until an unbalanced force acts upon it. And that's like the kid in the car. He's going to stay moving forward just like the car was until that seatbelt acts on him. All right, on page 61, you're just going to write Newton's law of inertia. You're not going to glue anything down yet. Then you're going to go to page 62, and you're going to glue down Newton's law of force and acceleration. Newton's law of force and acceleration states the greater an object's mass, the greater the force needed to accelerate that object. So if you're going to take a small box, you're going to push on it, it's going to move. But if you're going to take a big box, you're going to have to push on it harder to get it to move. On page 63, Newton's law of force and acceleration describes 2 relationships. The greater the force exerted on an object, the greater its rate of acceleration. So if you have 2 boxes of the same size and you push on one with a little bit of strength, it's going to move. But if you push on it with the same box with a lot of strength, it's going to move further. So make sure you glue those down on 62 and 63. Then on page 64, you're going to write at the top Newton's law of force and acceleration, and you're not going to glue anything down on that page yet. On page 65, you're going to glue down Newton's law of action-reaction. For every action, there is an equal and opposite reaction. So in the rocket ship, the action is the thrusters going off and firing. They fire down. The reaction is the rocket goes up. The action of this kid on the skateboard is him pushing with his foot. The reaction is he glides on the skateboard. These are bumper cars. It's kind of hard to tell in this black and white picture, but the action is the cars hitting each other, and the reaction is they bounce back. So that is action-reaction on page 65. And then on page 66, you're going to write Newton's law of action-reaction, but you're not going to glue anything down yet. So now that you have the laws glued down, you're going to take all of your scenario cards and you're going to decide what they're an example for. So you're going to find examples of the law of inertia, examples of action-reaction, and examples of force acceleration. When you find one, I want you to put it on the page, but I don't want you to glue it down yet. And that's why you have these blank pages, because you're going to need these blank pages to glue some down. You can glue some on the pages where you have the laws, but you can also glue some on the blank pages. So right now, I just want you to separate. I want you to pause the video, and I want you to separate your scenarios into 3 piles. One pile that gives examples of the law of inertia, one pile that gives examples of the law of force and acceleration, and one pile that gives the examples of action-reaction. When you have your scenarios sorted into 3 piles, you can unpause the video. So the law of inertia, you should have found 5 scenarios that were the law of inertia. It doesn't have to be the first one you glued down, but one of them that you should have found was when you put a book on the table before you leave your classroom and then your teacher locks the classroom door. That book, that object, is going to stay at rest while you're gone because no unbalanced force is acting on it. So that scenario needs to be glued down on one of your inertia pages. I'm going to glue it down here onto page 58. Another scenario that was also the law of inertia was you roll a marble across the floor. So that marble is going to continue to roll across the floor until an unbalanced force acts upon it. And the unbalanced force in that case would be the friction. So you need to find that scenario and make sure you glue it down on one of your inertia pages. I'm gluing it down on page 59. Another scenario for inertia was a magician yanks a tablecloth off a table covered with dishes. So when he yanks that tablecloth off, the dishes are going to move slightly, but they're not going to fall off because they're not being acted upon by they're being acted upon a little bit by the force of the tablecloth being yanked, but not with a great enough force to knock them off, so that's why they will stay at rest on top of the table. I'm going to glue this scenario down onto page 60. The last 2 scenarios that you should have found for the law of inertia was when you're in your car at a stoplight and when the light turns green, the driver floors the accelerator. So your car is going to stay at that stoplight at rest until it is acted upon by the driver hitting the accelerator. So that is the law of inertia. All right, and the last scenario for the law of inertia would be you're riding in a car and the driver makes a hard right turn. Your body is actually going to turn the opposite way because your body is trying to continue to go in the way that the car was originally going before it made that turn. So make sure you glue down all your scenarios for inertia. Now we're going to talk about the law of force and acceleration. There were 2, 3, 4 scenarios that you should have found for force and acceleration. A tow truck pulling a car races the same kind of tow truck not pulling a car. Okay, so we got the same tow truck, but one's pulling a car and one's not. So one's got a heavier load. The one that's not pulling the tow truck is going to go further because it doesn't need as much force to accelerate. So that is the law of force and acceleration. And I'm going to glue this onto page 62. The next scenario, you're driving an 18-wheeler next to a small compact car and the traffic in both lanes suddenly stops. Which car is going to be able to stop first? The small compact car is going to be able to stop first because it's got less mass. So less of a force is required to stop that car than to stop the giant 18-wheeler. We're going to glue this onto page 63. Our next page is going to be our last two examples of force and acceleration. Your car stops running, so you push as hard as you can, but you can't move it. That means you are not applying a great enough force to accelerate that car. And then the last one, the school bus is filled with students and the driver speeds up quickly. That driver is going to have to apply more of a force since the bus is filled with students in order to get that bus to move. Now, process of elimination, since we've glued down all of inertia and force and acceleration, you should know which ones are action-reaction. So you're swimming in a pool and you turn around underwater and push against the side of the pool with your feet. When you push against that pool this way, you push this way, your body goes the other way. That is action-reaction. I'm going to glue that example down onto page 65. The next scenario for action-reaction, or the next two because they're going on the blank page. A frog jumps from a lily pad in the pond. When that frog jumps off that lily pad, the frog's going to move and so is the lily pad. It's going to move in opposite direction. The frog goes one way, the lily pad goes the other way. And then the last example or scenario is a person steps out of a boat on a dock. When you step onto that dock, off the boat, you're stepping this way and the boat actually goes the other way. And if you don't have your boat tied to that dock, then the boat's going to float away. So make sure you study and you understand the difference between Newton's 3 laws of force and motion, because you're going to use those in the next few weeks to study and experiment with.